Welcome to today's lesson, and in our lesson today we are going to look at risks and returns. So what is a risk? Okay, so risk or uncertainty, okay, refers to the variability of expected returns, okay, associated, okay, with a given investment. Okay, so we are looking at the variability of the expected risks, so expected returns associated with a given investment. Now, one thing that we need to know is that these risks, okay, along with the concept of returns, okay, is a key consideration, okay, in investment and financial decisions. Okay, financial decisions. Now, as we are making those investments and financial decisions, you discover that there are things that are going to help us to make those investments and financial decisions. One of them is what we describe as the probability distribution. Okay, probability distribution. Now, what do we mean when we say probability distribution, or what are they used for? Okay, so probability distributions are used, okay, to evaluate the risk involved in a security. Okay, in a security. So therefore, okay, the probability of an event, okay, taking place is defined as the chance, okay, that the event will occur. Okay, that's what we describe as probability. For example, a weather, okay, forecaster may state there is a 30% 30% chance of rain tomorrow. Okay, and a 70% chance of no rain. Okay, so we're looking at tomorrow. There's a 30% chance of rain, and there is also a 70% chance of what? Of no rain. Now, this basically means that the probability, okay, could set up the following. Okay, could set up the following probabilities, distributions. Okay, so meaning we will look at the outcomes, okay, and also the probability. Okay, so when you talk about rains, the probability of rains is 30%, of which when you express this 30% is going to give us a 0.3. Then the probability of no rains is 70%. When you express that, that will be 0.7, like that. Such that when you add these probabilities, we're going to have 1.0. And when you add the percentage, we're going to have 100%. So the sum of the probability that it will rain and that of not raining is supposed to give us 100%. Okay. So another thing that's going to help us in making this decision based on investment and financial decision is a concept that we describe as the expected rate of return. Expected rate of return. Okay. Expected rate of return. Now, what is this so-called expected rate of return? Now, expected rate of return, okay, which is denoted by this symbol, is defined as the weighted average, okay, of possible returns from a given investment, meaning those weights being probabilities. Okay, probabilities like that. Okay, now mathematically you discover that this expected rate of return can be calculated in such a manner. Expected rate of return okay is equal to summation of the returns multiply by the probabilities. Okay, like that. So where this is the this is the possible returns. Okay, and this basically represents the probabilities, okay, of the returns then n represents the number of possible outcomes. Possible outcomes. Okay. For example, what an example. Consider the possible rate of returns that you might earn extra next year, okay, on a 50,000 investment on stock what? Stock A, or on a 50,000 investment okay, in stock B. Okay, depending upon the state of economy, boom, average, and recession. Okay, so those are three states of the economy. So start for stock A, state of the economy. Then we have the returns. Then we have the probability. Okay. So if this is boom, then we have average, then we have the recession. So we've got a 25% here, a 15% here, the negative 20% in recession. Okay. Then the probabilities for boom, I've got 30%. Average, we've got 50%. Then we've got a 20% in recession. Then for stock B, state of economy, then returns, then probabilities, okay, state of economy, we have got boom also, we have average, we have recession. So negative 20%, 15%, 25%. Then 30%, 50%, and 20%. So we are supposed to find the expected rate of return for stock A and stock B by using those returns and also the probabilities. Now, how do we calculate these based on the formulas that we had looked at in the previous slide? We're going to say that then the expected return for stock A is computed as follows. So we shall say R is equal to summation, of the returns multiplied by the probability. Meaning when you convert these percentages, the 25 here divided by 100 to be 0.25. The 15 there will be 1.15. Then negative 20 there will be negative 0.2, like that. So everything that's in percentages has to be converted. So we are multiplying the respective return multiplied by the probability, its probability, to be 0.25 multiplied by 0.30 plus 0.15 multiplied by 0.50, then plus negative 0.20 multiplied by 0.20, like that. So if you multiply there 0.25 multiplied by 0.30, it's going to give us 0.075. Then 0.15 multiplied by 0.50 50. It's going to give us 0.075, and plus there 0.20 multiplied by 0.20, that's going to give us negative 0.04 there, such that when you express that one, 0.075 plus 0.075 plus negative 0.04, we are going to have 0.11 like that. Therefore, we can be able to conclude by saying that the expected rate of return is equal to 0.11, which can also be expressed in percent as 11%. Okay, like that. Then we'll continue and look at for stock B. So I'm going to say that stock B expected what? Rate of return is, you say R there being equal to the summation of that to be R multiplied by the probability also. So if you look at B there, you discover that these were the percentages. Boom, negative 20, 15, on average recession 25, and their respective probabilities. So we also convert those things into their decimals. So we shall say that negative 0.20 multiplied by 0.30 there, plus 0.15 multiplied by 0.50, plus 0.25 multiplied by 0.20. Therefore 0.20 multiplied by 0.30, that one is going to give us negative 0.06. Then 0.15 multiplied by 0.50, it's going to give us 0.075, plus 0.25 multiplied by 0.20, it's going to give us 0.05 like that. Therefore, we can say, if you express that one, our answer will be 0.065. So we can say that the expected rate of return is equal to 0.065, which you can also express in percentage as 6.5%. So that is basically telling us that if you want to invest that 50,000 of yours, you'll discover that if you are to use it in stock B, there is a rate of 0.65 that can be able to be generated. But if you are to use it in stock A, there is 11%, which can be generated from that investment. So you are able to make a very viable financial decision with your investment. Okay, we continue now. In as much as you want to make this investment, it's also very important to ascertain the risks that are associated with each investment that you are making. So in order to help us understand these so-called risks, we'll now have to look at the standard deviation for these stocks, so that we can be able to know where can we be able to invest or to make an investment, okay, on which asset can we be able to make an investment, so that we may be able to maximize our investment, while at the same time being able to minimize the risks. Okay, so we'll look at the standard deviation. Okay, so I would say measuring risks. Measuring risks. So the first thing that we'll look at as we measure this risk, it is a standard. A standard deviation. Okay, that's a symbol there. Okay. Now, what is this standard deviation? So, we are saying that the standard deviation okay, which is a measure of dispensations of the probabilities, okay, of the probability distribution. Okay, so this standard deviation, will discover that it is commonly used to measure the risks. Okay, to measure risks. Now, the smaller the standard deviation, smaller the standard deviation, okay, the tighter the probabilities. The tighter the probabilities, okay, or we can say the probability distribution, okay, and thus the lower the risks of investment. Okay, now the question is, how do we calculate this so-called standard deviation? So standard deviation is the square root, okay, of the variance. Standard deviation is the square root of the variance. Now the question is, how do we find that variance? Okay, that is the summation okay, that is the return minus C, the expected return, okay, squared, then multiply by the probability, like that. But how do we calculate it? So, to calculate Okay, the standard deviation would say take the following what? The following steps. Okay, take the following steps. So, step number 1. Okay, step number 1, compute the expected rate of returns. So meaning the first step is for us to calculate the expected rate of return, which is this one here. Okay. Then step 2, okay, subtract, okay, each possible returns, okay, from the expected rate of return to obtain a set of deviation, which is R minus C, the expected return. Okay. Go to step number 3. Step number 3. Square each deviation. After you square it, okay, you have to multiply it. Multiply that deviation, multiply the squared deviation, okay, by the probability. Probability of occurrence. Okay, for its respective return. Okay, and then after that you sum those products. To obtain, okay, the variance, okay, which is like that. So meaning variance is equal to summation of n being equal to R, which is the rate, expected rate of return, sorry, the rate of return minus expected rate of return. You square, then you multiply by the respective probabilities. Then once you find that, we can now go to step number 4. Okay, we would say finally, okay, take the what? Take the square root. Square root of the variance okay, to obtain the standard deviation. Okay. So these steps are very necessary and they are going to help us. So we can look at our examples. Okay. So we would say, based on the previous examples, okay, previous examples, okay, we'll start with stock A. Stock A, we have the rate, we have the probability, this is the return and the probability, then return multiplied by the probability, okay. Then here now we are going to have the return minus the expected rate of return. Then here it will be the return minus the expected rate of return, then you square. And lastly, we're going to have the return minus the expected rate of return square, then multiply by the probability. Okay. So what do we do there? We'll start from stock A. So stock A, I remember we entered such information as the 0.25 on the return, then 0.15, then we had the negative 0.20, then the probability 0.3, 0.5, 0.2. Now on this one you are multiplying the return multiplied by the respected what? Probability. Okay. So when you multiply 0.25 multiplied by 0.3, it's going to give us 0.075. Then next, 0.15 multiplied by 0.5 is going to give us 0.075. Then negative 0.20 multiplied by 0.2 is going to give us negative 0.04, like that. So when you find the sum of this, okay, this is what we are calling as the expected rate of return. So our expected rate of return there will be 0.75 plus 0.75 minus 0.04. This is going to give us 0.11, like that, as our expected rate of returns. Now, in the next one, okay, in the next one, we look at this. Remember, this is our step 1. This is step 1. Then I think step 2, it deals with this one. Then this is step 3, and also this is part of step 3. Okay. So now we are now going to subtract to find the deviation of the return minus the expected return. Meaning for the first one, it will be 0.25 minus 11.11. That's going to give us 0.14. Next one, 0.15 minus 0.11. That's going to give us 0.04. Last one, negative 0.20 minus 0.11 is going to give us negative 0.3 Okay. So if you square this, square 0.14 is going to give us 0.0196. Okay, 0.04 you square it, it's going to give us 0.0016. Then negative 0.31 you square it, it's going to give us 0.0961. And after you square those, you will need to multiply them with a respective probability, meaning 0.0196 multiplied by 0.3. That's going to give us 0.00588. Then the next one, 0.5 multiplied by 0.0016. That one is going to give us 0.0008. Next one, 0.2 multiplied by 0.0961. It's going to give us 0.01922, like this. Remember, still under process 3, so it's step 3, we are supposed to add these values there. Okay, so when you add them, they're going to give us 0.0259 there. Okay, as a sum of those deviation multiplied by the probability. Now, once you are done, once you are done with the that variance there, we can go to step 4, because we are told that the square root of the variance is what's going to give us the standard deviation. So we would say that knowing this one is equal to 0.0259, like that. Okay, we can proceed to find what? To find the standard deviation. So, which is found in step what? Step 4. Okay, so I'm going to say that the square root of that figure there which is 0.0259 like that, is equal to, is equal to is equal to 0.160935, which can also be expressed as a percent, which will be 16.09%. Okay, like that. That is for stock A. Okay, we can continue even as we do the same for stock B. So we'll say stock B. How do we find that? We are going to use the same example where I've got the returns. We have the probability. We have return multiplied by probability. Then we have return minus expected rate of return. Then return minus expected rate of return squared. Then return minus expected rate of return square. Then you multiply with the probability. Okay, so our first one, that is the negative 0.20. Then we have 0.15 and we have 0.25 there. Okay, the probability 0.3 and 0.5 and 0.2. So when you multiply the return multiplied by the probability, for the first one it will be 0.06, second one 0.15 multiplied by 0.5, it's going to give us 0.075 there. Last one 0.25 multiplied by 0.2, that one is going to give us 0.05. Okay, the summation of that is what we are describing as the expected, okay, rate of returns. Expected rate of returns, okay, which is negative 0.06 plus 0.075 plus 0.05. It's going to give us 0.065 there, like that. Now, this 0.065, remember, this is our step 1 here. This is our step 2. That is our step 3. Okay, and that is the part of the step 3 also. Okay, so what do we do there? We'll now subtract the return minus the expected rate of return. Meaning for the first one, it will be negative 0.20 minus 0.065. It's going to give us negative 0.265. Okay, next I'm going to say 0.15 minus 0.065. That's going to give us 0.085. The last one, 0.25 minus 0.065. It's going to give us 0.185, like that. We continue. When you square these values, which are on step 2, the derivation, square 0.256, 0.265, it's going to give us 0.070225. Multiply it with its respective probability, which is a 0.3. It's going to give us 0.021065. Okay, you square what is on step 2, number 2 there, 0.085. It's going to give us 0.007225. Multiplied with its respective probability, which is 0.5, it's going to give us 0.0036125. The last one there, which is 0.185, square it, it's going to give us 0.034225. Multiply by its respective probability, which is 0.2, it's going to give us 0.0068 and 5. So when you add these values, they are going to give us the variance, which will happen to be 0.03125. So this is basically representing the variance. Okay, once you find the variance there, we can now say, okay, knowing, okay, that this is equal to 0.0313525, like that. So we can find the square root of that value, because we know that square root of the variance square root of the variance is the standard deviation. So we can proceed with step number 4. Okay, so and this square root of 0.03125, it's going to be equal to 0.1775, like that. Okay, so we can therefore say that standard deviation is equal to 1775 and 17.75 if you want to express it as a percentage. Okay, so let's go to the last part now, which is the measure of relative risk. Okay, measure of relative what? Risk. Measure of relative risk. of which this one can be found by the coefficient of what? Of variation. Okay, so the coefficient of variation is computed, okay, computed simply by dividing the standard deviation for a security. Okay, by expected what? Expected rate of return. So, what do we say on this one? Okay, the higher the coefficient of variation, the coefficient of variation, okay, the more risky, okay, the security. Okay, meaning those ones with high coefficient of variation, they tend to be more risky. Hence, if you are told to choose between two securities, it's better you choose the one with a low coefficient of what? Of variation. Now that we have been told that this coefficient of variation, okay, can be calculated by dividing the standard deviation divided by the what? The mean. Okay, or we can say the expected what? Rate of return. So for stock A, okay, for stock A, I'm going to say that coefficient, okay, of variation is equal to expected return, which will be 0.160935 divide 0.11, and our answer in this case will be 1.4, okay, 63 as the coefficient of variation. What about for stock B? Say coefficient of variation is equal to standard deviation, expected rate of return. So our standard deviation there was 0.1775 divide 0.065. What do we get there? Going to get 2.73 So if you look at that one, you discover that stock B is more risky as compared to stock A. Why? Because it has got a higher coefficient of variation.